So yeah, it was a great opportunity when Bart asked Liz and I to sort of give this presentation. The the first time Liz and I did this presentation was earlier in June for the One Ed Tech Learning Impact Conference. Um, and I think, this is speaking from my own experience at that conference, I think this project was a really good representation of sort of what we envision a partnership with a member institution with Unizin looks like. That's, when we're thinking about taking learning analytics data and putting it into action, I think the way that Penn State is able to do this, given some of the infrastructure that Unison provides, is meeting some really good needs for their institution. So really excited to share some of the work. Really, it's Liz's work with you guys. Some quick intros. So my name is Kyle Unruh. I'm the Director of Data Services and Solutions at Unizin. I've been at Unizin over 5 years now. And it's, over the time, our service model and sort of the data offerings that we have really evolved. And it's been really exciting to see. And during my time here, I've gotten to work with some really great individuals, and Liz is one of them. And so I'll hand it over to Liz, and she has the first part of the presentation as well. So, Liz, off to you.
Thanks. My name is Liz Seidel. I am coming from Penn State. I've been in my current position as a data scientist on the data empowered learning team for about 2.5 years. Before that, I worked as a data scientist for an external company. And really, what we focus on is helping to provide learning analytics tools to the university. Across the board. So with that, I'm going to jump in and talk a little bit about a project that we worked on over the past year or so. If you want to, thank you. So I'm going to talk about how the team I'm a part of at Penn State built basically a new metric to get real-time insight into students' performance and course engagement. I'll start by giving sort of a high-level overview of the project that we did, and then Kyle is going to dive into the Unizin Data Platform and Unizin Data Marts and show you how those tools can be leveraged. And I'll speak a little bit to how I leverage those tools for this project. For anyone who's seen The Matrix, bear with me for a second. I'm going to give a quick summary so that some of the references aren't lost on people. So in the movie, humanity is sort of unknowingly living in a simulated reality that they call the Matrix. The main character is Keanu Reeves' character Neo, and he meets a guy, Morpheus, who offers him a choice. He can take a red pill and see the truth, or he can take a blue pill and go back to life as he knows it. Not surprisingly, for the sake of the movie, Neo takes the red pill and wakes up to a reality far different from anything he could have anticipated. So today, we're going to tell a story of Penn State's attempt to kind of red pill our faculty and advisors, and how Unizin has played the role of Morpheus by helping to accelerate and enable that process. If you want to hit the next slide, thanks. So, at the heart of this project is really a simple goal: supporting our students' success. We've asked ourselves a few questions. Can we build something that is action-oriented and supports high touch points with students? Can we give advisors and instructors better data so that they can make decisions in real time, not just at the end of the term? And can we provide a way to understand students' engagement and performance as it's happening rather than after it's too late to intervene? To understand more about why this project matters specifically for Penn State, it helps to have some context. So we're a large public university. We have 24 campuses, nearly 88,000 students, close to 8,000 faculty, and over 275 undergraduate majors. With that kind of scale, Penn State operates more like a large enterprise in some ways than a typical university. So advisors and instructors are responsible for huge numbers of students, which makes it difficult, if not impossible, to consistently support them in proactive and personalized ways. So why is real-time student support so hard for us and sort of the problem that we're trying to solve with this project. First, Penn State does not allow real-time grade sharing with non-instructors, which means our advisors don't have access to live grade data. They only see grades once they're finalized. Second, we don't require any sort of standardized use of grade books or a consistent use of our learning management system, Canvas. The Canvas usage as a result of that varies widely across courses, and gradebook data is not necessarily reliable or consistent enough to act on in and of itself. Technically, we do have tools like mid-semester reporting that are linked to our advising platform, Starfish, where faculty can flag struggling students, but there's no consistent mandate on the use of them, and so compliance will vary a
Um,
lot from instructor to instructor.
so
Oh, okay. Uh, the result of all of this basically means that advisors are kind of working in something like the matrix or a matrix like state during the term until the end of the term without access to these more timely signals about which students might need support. At the same time, instructors may be responsible for hundreds of students, making it difficult to recognize when any single student might need help or be struggling. Thanks. The team I work on exists basically to close that gap between reality and this matrix light state. We are a data science group focused on improving student success, student experience, and student support through analytics. We built learning analytics tools that operate at scale and deliver real-time insights across the university. And importantly, we already have the infrastructure, tools, and data pipelines in place to make real-time analytics scalable. So one tool that we already support is called Elevate, which is an advisor-facing tool. Here is a glimpse of sort of what a landing page would look like for that for an advisor. Advisors can see their full rosters. They can drill into individual students, view their academic history, their current enrollments, their Canvas activity trends within specific enrollments, Starfish tracking items, and more in all one consolidated hub. This tool is already widely used across the university right now as well. But what was missing was a consistent way to understand real-time student performance in a more consistent, predictive, and contextual way than basing these insights sort of piecemeal on different, sometimes inconsistent and unreliable metrics. So now we get to make the choice. Do we want to take the red pill and accept a challenge of building something new and different to understand this current state? Or do we take the blue pill and just keep waiting till final grades tell us what already went wrong? So that choice led our team to what we're calling the performance outlook and the performance outlook metric. Today, I'm going to mainly talk about this from the perspective of an advisor and the use case of an advisor, but I just want to note that this metric is really designed for a large range of users, including instructors and staff in mind too. So we built this new metric that gives advisors and instructors basically a weekly assessment of a student's risk of falling below a C in a given course. The model is multifactorial, meaning it picks up on more tenuous signals that wouldn't be obvious through current flagging and activity tracking alone. And it's inspired by the idea of a weekly weather outlook. So advisors can see trends emerge across the weeks of a semester, as well as just looking at the most recent risk prediction for a student. This makes it much easier to identify students who might otherwise be flying under the radar. So the model predicts, as I already mentioned, weekly risk of students, and it does this by comparing students to historically similar students. It uses three main categories of features or input variables. The first being course level data, things like courses historical C rate. We also have student level data that's sort of stable across the whole semester, like a student's incoming GPA, a student's personal history of late dropping and withdrawing, things like that. And then lastly, we have real-time indicators like students' weekly Canvas activity, students' gradebook performance if it's available, students' tracking items, and various other things that we'll talk more about. So by combining all of these, it gives the model enough context to make hopefully more meaningful and robust predictions than it would otherwise. We can also measure what features matter most to the model. This chart shows the top 15 most influential features. You'll see inputs like prior GPA and historical course difficulty show up near the top. A key takeaway of this slide, though, and kind of why we're all here today, is that 9 of the top 15 features actually come from data that we're getting from Unizin. That data either comes from our event data pipeline, which we query from the UDP and process to be in a specific format that we want to work with, or it comes pretty much, and we use it in its raw form from the Unizin's curated data marts. And this data plays a major role in the quality of our predictions. So this really reinforces a core idea that students' performance is not driven by one signal. It's the result of many overlapping factors. So now that we've trained the model, we have kind of an overview of what goes into it. We've learned Kung Fu, as Neo had said. What do we do with it? So this is what an advisor would see, and I'll kind of walk through what an advisor would see in the next couple of slides. Each student receives a weekly risk score that's rolled into kind of a stoplight system of, red being the most severe risk, yellow being, hey, you might want to pay attention to this student, and green being, hey, we think they're probably okay. It allows advisors to quickly spot patterns over time, as you can kind of see here on the weekly progression, but it also allows them to sort their students more nimbly. Importantly, we intentionally do not show exact grades because of some of the things I mentioned earlier about Penn State's policies, and we also don't show any other sensitive data. We want to equip our advisors with insight, but not automation necessarily. So in addition to the Outlook score, there at the top across each week, we also give advisors a subset of metrics that actually feed into the model, but they might be helpful in and of themselves. So using Unizin's data marts, specifically the task force data marts, we surface things like number of missing assignments, workload volume, and gradebook percentiles. We also combine Canvas activity and any advising flags that may have been raised to show those in the view as well, if it's available. Sometimes the availability of these data might vary quite a lot across courses. But all of this allows advisors to move from insight to a conversation with their students. Not just that a student is struggling, but also providing some more helpful context that could contribute to why they're struggling and initiate some sort of dialogue with them. Okay. So this slide is just to give you an idea of another student who might not be doing so hot by the looks of it, and what that might look like to an advisor. So you see the risks there up at the top, and you also see some, bullets about essentially some things going on in the class that may or may not be contributing to the student's risk of doing poorly in the course. Okay, so then advisors can use this metric and we can roll it up to one level higher, and they can see how a student is doing across all their courses at once. And this is helpful because it can identify patterns, such as if a student is struggling across multiple courses or if it's an isolated incident. And that might determine how they decide to reach out to that particular student or how they frame their conversations. We can zoom out even more to an advisor's entire caseload. From there, advisors can quickly find students at high risk and then drill back down into the individual students and their enrollments to see what's really going on under the hood. And everything updates weekly, reinforcing this real-time action and real-time stats about the student. So, what's next for us with this project? The metric is already embedded into our existing tools that our team has built. Um, and it's in multiple tools that support different use cases. So I spoke today about Elevate, which is for advisors, but we also have something called Course Insights for faculty, for example. Right now, this project is in pilot phase with a subset of faculty and advisors. We're collecting feedback about what works, what doesn't, how can we improve on training, how can we improve adoption, things along that nature. The feedback has been overwhelmingly positive, I would say, but maybe I'm biased and I only pay attention to that. But we have got a lot of positive feedback from faculty who validate sort of the gut check of, yeah, these predictions feel right after looking at them and final grades come in. We've also heard a lot of great stories from advisors who use this to reach out to students that they maybe otherwise wouldn't have noticed. And from a modeling perspective, we're constantly improving performance, coverage, methods, explainability, lots of moving parts with that, as well as playing around with different metrics from Unizin's data marts, which is on my to-do list for January. So moving forward, we're also planning to work with leadership on how this project might scale in the future. So with that, that was a pretty high level overview, but hopefully gets an idea in your mind of what we're doing with this project. I'm going to pass it off to Kyle, who will be able to share a little bit on how Unizin provides us with their oh so helpful red pills.
Awesome. Thank you, Liz. I remember early days when we were trying to initially meet and put this presentation together. Liz had the idea for the Matrix theme, and she sort of positioned it as Penn State as the Neo character and Unison as the Morpheus character. And it was overwhelming enthusiasm for me because Morpheus is my favorite character from the Matrix. So I was like, no question, this is exactly what we're going to do for the presentation. Neon green, black background, red text. It was so fun to put together. So yeah, let's take some time going into the Unison side, the UDP side. Um, and I kind of think about this as a red pill factory. So if you'll bear one more set of metaphors, we'll go pharmaceutical a little bit. Um, there are a lot of familiar faces here, but some others that I'm not sure just how much people know about the UDP. So I'll start with sort of first principles of the UDP. It's centered around three main ideas. The first is to unify the teaching and learning data ecosystem. I think we all sort of understand the reality of every vended tool sort of has their own schema, their own sort of exposure to backend data, their own sort of out of the box reporting. And there's not an emphasis from these often for-profit vendors to have a cohesive, unified view of what's actually going on in a classroom. So the UDP wants to build that unified view. And we want to do that by commonly modeling, coalescing, and basically making that data all speak the same language. So we have data standards that we enforce on top of the UDP that make sure that if there's multiple tools that have the same concept of a person or the same concept of a course, that data, regardless of where the tool comes from, or where the data comes from, which tool, it looks more or less the same. We can still identify the source of that data, but the downstream reporting and the presentation of that data can be unified. And given the first two principles, we're able to build data marts and services on top of the UDP. And that's really what has accelerated this development of the performance outlook. Those 8 or 9 features that are in the top 15 most important features that Liz mentioned, these are the data marts and services, or the output of the data marts and services that Unizin commits to providing its members. So given all of these, the UDP exists as a data platform on Google Cloud. Folks often access it via BigQuery, although there is also like Google Cloud Storage interface. There's a Postgres database. I don't think the purpose today should be the technology behind the UDP and the details of that. Just know it's a cloud native solution that has real pseudo real time teaching and learning data flowing into it that meets these 3 main ideas. So continuing the pharmaceutical metaphor, the data standards that we have, the FDA, that's for the UDP, are twofold. The 2 main data streams are the context data stream and the behavior data stream. I might also use the term event data to mean the behavior data. I sort of use those interchangeably, so bear with me there. On the context side of things, this is very rich descriptive data. So a lot of tables that join relationally. We serve these natively in a Postgres database, but these also feed into BigQuery. They're very rich in description. There's a lot of primary keys and foreign keys, such, for example, course offerings to course sections to enrollments in those course sections. Those are all sort of tables that can be joined together. And these are really suitable for batch processing. So we ingest this data once per day currently. And the data standard that's on top of this is the Unizin Common Data Model. It's our homegrown standard, but it is based off of the SEDS model. So it's not just pulled out of thin air. It's sort of based off of SEDS and then enriched in a way to sort of make it our own. The second stream, the behavior data stream, is very thin in description. And what we mean by that is it's essentially one giant table that continues to, in real time, append data. And this is the clickstream data that Bart mentioned earlier, the 13.8 billion events. This is the behavior data stream across our member institutions. And the data standard that's enforced here is the One EdTech Global Caliper standard. And these are JSON payloads that have blocks like actor blocks, so we know IDs about who sort of did the action. We have EDAP blocks, so we know where the tool that emitted the event. We have the object sort of blocks, so we know what was interacted with. And then we have like event type and event action, so we know what sort of activity was happening. I don't have necessarily a JSON payload to look at. I don't think it's important, but these can sort of read like sentences in a way. And that's sort of the nature of the Caliper standard is through JSON, you can sort of understand a sequence of clicks and a sequence of behaviors that a student is doing in their course. So these 2 data streams together are what make up the Unizin Data Platform. And this is the basis on which we build data marts and services. So yeah, context data plus behavior data yields data marts. And we call these, for the pharmaceutical metaphor, prescriptions. And these are use case driven assets. So Unizin does not just make data marts because we think these data marts should exist. This is the result of community input and feedback and learning about the challenges that our members face and doing what we can with our resources to help meet those challenges. Some examples of data marts that are available to all Unizin members currently, the last activity data mart. So from an engagement use case, when was the last time a student clicked on anything in their course? And then we can also look at different types of clicks and different types of assets that are being clicked on. File interaction. So if I'm an instructor and I uploaded a really important PDF, have students actually seen that PDF? So that relies on the context data to describe the files and also the behavior data for tracking clicks to those files. Course status. This one was really important in the weird post-COVID limbo that we experienced in 2020, 2021. When there were a lot of instructors that weren't used to teaching hybrid or fully online, there were a lot of instances where courses existed, but they were not published. And so day one of the term, students could not see anything for their digital learning environment, even though the instructors could see things from their point of view. So the course status mark looks at published times and also just very high level aggregate stats about what exists and what does not exist in courses. LMS tool use, this tracks clicks across Canvas. So it clicks to discussions, clicks to the calendar, clicks to assignments and quizzes. An interesting use case here for this data mart could be tracking sort of like a network graph, the hotspots of activity inside of a course. Where do students gravitate most when they go back to their courses? Interaction session, and I won't go through all of these in detail, but just to give you a flavor, interaction session is given a sequence of clicks. How do we group those together into times that we know a student was engaged with course context? So if there's 8 hours of time between clicks, they probably weren't spending all that time learning. But if there's 10 minutes between clicks, they were probably sitting down and working on an assignment or doing something meaningful for that course. So given a sequence of behavior clicks, how do we logically group those together to determine meaningful chunks of activities? And again, we partner with our members to define and build these. It's very common that we have a lot of iterative cycles to refine these data marks, and we have releases that we occasionally do. In fact, there's a release going out next week on the 9th to further refine and improve these data marks based off of feedback from our members. The one in scope here, though, for the performance outlook is the task force data mart. And I put the task force in quotes because this was a 2022 initiative by Unizin to sort of jumpstart more data mart development. We had a handful of marks in 2022, but we definitely needed a push to kind of get more out there. Like we saw the value of the first 4 or 5 data marts, but we needed a real focus to sort of boost the presence of data marts. And now we have, I think, 14 or 15 data marts now. So I think it was useful. I put it in quotes because the name task force doesn't really mean anything anymore, but we're stuck with it because it's a hard asset that now has dependencies. So we can't change the name. And I wish I had the foresight back then to not name it the task force data marts, but here we are. The focus is on advisors and faculty. So characterizing sort of the experience in courses and doing it in a weekly view. So like, what is the activity at week 1, week 2, week 3, all the way through finals week? And I like to, in my mind, visualize like if there's a line chart, we could have the x-axis be weeks and the y-axis be something we want to track for our students. And then we could see things increasing or decreasing over time. And that could give some interesting insights about how students are doing in our courses. So again, the scope, yeah, per person, per course, per week, and sort of the net that we cast in terms of learning data is around assignments, discussions, and activity. We really just want to characterize, again, the weekly behavior and experience of students in courses through this data mart. There are a few different tables that compose the task force data marts, and then we call them different levels. The levels really mean sort of dependencies. So level 1 is sort of the entry, and this is the per course per week per person. And we define a week Sunday to Saturday. We're tracking things like numbers of files clicked, number of assignments submitted, number of discussions completed, number of tools launched, assignments that were due and assignments submitted, and also characterizing that by weight, so major versus minor assignments. A lot of just beads that are being counted, I guess, per person, per course, per week that we can see. And the purpose there is just weekly aggregations. On top of that, we have level 2, which is per course, per week. And 2 tables results of that, and they both have a single dependency on the level 1 table. The one that we call the distribution summary, and this is the fictitious average student. So for a week, if there are 10 students in the course, we can take their all that weekly activity and determine the average student. So what is the average experience and average behavior? That exists in the distribution summary table. And then based off of that distribution summary table, we can then do things like z-scoring all the 10 students based off of that average student. And that sort of helps with ranking in a way without having to show data that might be too sensitive based off of your institution's policies. So Liz's example, advisors can't see real-time grades, but they can see percentiles. So something like a z-score table based off of the average can give real sort of insights that advisors or other individuals may need without sort of bypassing any university data policy. I also put level zero tables on there. These are sort of descriptive tables that don't really have the per week or the time component to them, but these are per course and per student descriptive tables. We call them profile tables. And when we were making these, we knew we needed helper tables so that the code wasn't too unwieldy. And these are just really good sort of holistic views of courses and students. So we surface them as marks as well. We'll share this slide deck with everyone after, and these are clickable links. And where these links go is to our resources site, where there's each of these data marks is has the schema, where it lives, its table name, and also sort of like if there's metrics and calculations and filters, it's the full documentation is there. So going back to this feature importance of Liz's ML model, we want to focus on the brightest green bars. So the cumulative published gradebook score, cumulative published gradebook percentile, relative number of 20-minute sessions. These all come from a single data connection, a single table that is updated once per day. And none of that code was code that Liz had to write. And that's sort of the vision that we have for Unizin working with our members. Unizin does not have domain expertise to create this model, but Liz also does not have to go into the raw data herself and learn how to create all of these features herself. So what we're trying to get better at over time, and we would love feedback and more engagement, is what is that ideal interface between Unizin and our members? And I think this is a good representation of how that can be successful and actually optimize and improve the efficiency of creating some of these models.
Yeah, really fast, Kyle.
Yeah, go for it.
Just to underscore what you're saying. So, for example, in this plot, whenever he said relative number of 20-minute sessions, that's a great example of I'm literally using the raw field from one of the z-score tables. I wrote the field name in something that's human readable for the sake of this presentation, but I am using essentially raw data right from the data mart in that instance to feed into the model because it's already in the format that I structured all my other data in. And just to, emphasize Kyle's point about the time saving aspect of this, I think, if I were to estimate being able to tap into these data marts, probably saved me multiple weeks, if not months worth of tweaking, writing code to get things in a format in such a way about data I'm not nearly as acquainted with as the folks at Unizin. So I can't emphasize that point enough. Anyway, sorry, Kyle.
Awesome. No, great. Thanks, Liz. Really appreciate that. That's actually a great segue because the relative number of 20-minute sessions. The next section is sort of the most technical section of the presentation, and the purpose here really isn't to just sort of glorify one of the metrics. It's to sort of show where Unizin's expertise, like sort of where we focus our time. So when we think about a data mart and we think about what a meaningful metric would be, these are the sort of considerations that we think about. And when we get service tickets or sort of community feedback that something needs to adjust or change, we often go back down to this level and look at some of our definitions of these metrics and then adjust them, and it percolates back up into some improved deliverable for our members. So this is the deep dive, and the 20-minute sessions I think is a good example. There's not like a textbook definition of an interaction session. This is a Unizin homegrown sort of concept. It's not unique to Unizin. There are other concepts of sessions, but this is sort of where we've drawn our line in the sand. So the purpose of a session is, again, to group together meaningful clicks of activity so that we can approximate the amount of time a student is engaging and how often a student engages with their course content. So assume that there's a student, and these are the timestamps of a 3-hour window that a student is making some sort of clicks in an LMS course. So like from A to B, there's 3 minutes. Between B to C, there's 11 minutes, and so on and so forth. And there's a sequence of, I don't know, 15 clicks, whatever letter, whatever index M is in the alphabet. That's how many clicks there are. What we can do though is have an opinion about these clicks, and this is where Unizin's definition gets sort of enforced on this. The 20-minute the 20-minute name for this session is how far the max time between clicks is before we say that there's a new session that has started. So if the time duration between click A and click B is less than or equal to 20 minutes, we include that time as part of a single session. If it's greater than 20 minutes, then we say that the first session has stopped and then a new session could have started. So all of the clicks for session one here between A and E are less than 20 minutes, but between E and F, it's 22 minutes. So we do not count the time between E and F as part of that first session. We assume that since 20 minutes is our cutoff, that the student has context switched into something else. And so session two actually starts on click G through K, and then there's a small session then between clicks L and M. So there are 3 total sessions, and you might notice that click F is excluded. Um, yeah, we do exclude that. And that's partially because based off of Unizin's opinion, click F is sort of an anomaly. It's an outlier. So we don't know if there's anything meaningful that happened with that click because we don't know any subsequent activity that was close enough in time based off of that click. Um, so then what we do in order to create the metrics that are then used for Liz's model is we given the grouping, the clustering of sessions, we count the number of clicks, we count up, and then we count up the time, sum up the time, and then we have something like a total clicks, number of sessions, and total time interacting. And that would be at a weekly level, but would be in the level 1 table, the per course, per person, per week field. And then going back to the the relative metric that's into the model, we would take that and find the average, the fictitious average student for that week. And then we would calculate the z-score based off of the average student's 20-minute sessions for that week. So those are sort of the levels of calculation and aggregation that Unizin does to create and surface something in a data mart. So to be sort of just in a going from source data, where Unizin on the far left, the UDP is sort of that source data, ingesting all the tool data and putting our standards on it. We can then have our opinionated metrics for the 20-minute interaction session, and then we can aggregate that up into the relative sort of holistic weekly view of student activity that then gets fed into a model. And then Liz can take that and feed it into the performance outlook model. And so everything in this is the red pill then. The first 3 boxes are the red pill, and this is what Unizin is responsible for. And that interface on the right side between data mart and application is where we're really interested in. What's the right balance for your team's resources and your priorities with what Unizin can provide with our expertise on source data and our data standards? So I'll just take a couple more minutes, and this is admittedly a Unizin community plug. So how do we make more red pills? It requires our community. Unizin does not just sort of sit and sort of think about, well, what would be an interesting sort of data mart, and then try to find a use case for it. We want to know that there's a challenge or there's a priority from our member institutions, and then make sure that we have a solution that meets that specific need. Granted, we do want it to be generalizable to meet other needs as well, but we always want there to be value. We really don't want if we build it, they will come sort of mentality. We want to make sure that we're meeting our members' needs and adding value that way. So I have just a few examples of this in action. The student activity score is one. Again, these are all links that go to the data mart documentation. This started as a project at IU with Matt Rust and Josh Quick. To advise an advisor-facing application that is now scaled out to every Unizin tenant. We worked with them on sort of their logic. It's a very successful activity score metric for them. I think they saw double-digit increase in retention of students with this score, and now every Unizin institution has this. There's the links data mart. So Jason Hefner wrote a very useful utility to extract URLs across the entire Canvas instance. And I think I have this right. Correct me if I'm wrong, anyone on the call, that there are a lot of broken links, and broken links are hard to find if you don't have something to sort of aggregate everything together. So I think that was the genesis of this. But we took Jason's code, generalized it to work with our UDP data mart sort of structure. And now everyone has a data mart that updates every day that shows every link that's embedded in Canvas. And then the last two, learning environment organization. Canvas accounts are have a very deep hierarchy with like a parent account and a grandparent account. It can be hard to sort of know how deep the tree goes. So we took the Canvas account structure and we sort of denormalized it into a very wide table. But now you can sort of see for a given Canvas account, you can traverse the tree all the way back up to the root account and see its exact membership. Daily course grade record. One quirk that we get with Canvas data is that we only see the latest snapshot of course scores. So we don't know the course score a week ago. We know the course score as of yesterday. So we have a daily appending table that gets the latest snapshot. And now it's like an archive where we can be at the end of a term. But if we want to know what the course scores were like at week 6 or week 7 of the term, we can go back in time and basically rewind the clock and see exactly what course scores were, and we can see how they trended up or down for individual students and courses. These all came from our members. These are all ideas from our members. And the ways to get involved are the TNL groups, hackathons, the town halls, and we have a Slack space. So if there's any interest to get involved, we would love to meet you if we haven't met you already. Reach out to info@unizin.org and we will get you connected to the right group. All right. Thank you, everyone. I think we now have some time for questions.
Yep. Thanks, Kyle. Thanks, Liz. We have at least 14 minutes. So folks can either put questions in chat or you can unmute and ask questions if you'd like. And I guess I'll ask the first question while folks are formulating their own. Kyle, you walked through the 20-minute session length idea. Are there also data marts for different session lengths outside of the 20-minute session length, or is it just the 20-minute?
Yeah, so we have 10-minute sessions and 30-minute sessions that are also available. We've written the code in a way, though, that if there's a need for a different cutoff, it's not difficult for us to surface that. We did have to, it's sort of a heuristic, though. So we kind of had to decide. We gave 3 different options, 3 different flavors, I guess, for sessions.
I have a follow-up question to that actually. Because I noticed in the presentation you mentioned there was like that lone click, like click F or whatever that you labeled as an anomaly. I mean, I guess my first question is, in the same way that people can choose the time length if needed, could we also pick if we want to retain those and then like we could decide? I was just thinking of one, I guess my other question is like, what's the rationale? Because I was thinking like, for example, a student might launch external tool like a textbook, and to me that's a meaningful, like, yes, it's a loan, but it indicates like in some course context a regular thing that students should be doing is going in and opening up the textbook or going to or maybe there's one page where the instructor has embedded many external links or something. It makes sense they would actually click one thing but with regularity. So I'm just curious about that, if you could say more.
Yeah, absolutely. That's a great question, Solomon. So you're right that sort of like if the time between E and F and F and G, there could be some really meaningful activity that's happening. We just have a blind spot in the data. So when we were making this data mart, we sort of look at the interaction session time as a floor calculation. Like the amount of time being spent is not less than this amount of time. But yeah, we're often sort of bound by the visibility that we get from tools. So whenever we are working with tools like Packback or Top Hat or Kaltura, a lot of it is to solve what you just pointed out. Like we still have blind spots in the data, and our approach to sort of solving that is with more tool integrations. So if we get more tools fully integrated with the UDP, I'm sure there will be more clicks and more meaningful events that happen between E and F and G that we can measure. It's really just a limitation of what we can measure. For the first part of your question, is there a way we can include that? Yes, we can do like a total clicks sort of metric. And I don't remember the exact schema of the interaction session table, but there might be a total clicks and then a clicks within sessions sort of metric to give you an idea of how many orphaned clicks there are. Uh, but
Or
I would be
just if,
curious.
like, I
Yeah,
might,
sorry, go
for
ahead.
example, in the context
Yeah.
I'm working in, I might be
Hmm.
totally comfortable just calling that 647F click another session, like it was a session.
Yeah,
Like I don't know what
a one
happened
click
in it,
session.
but exactly,
Hmm.
but or I may actually be able to know some, like I said, in some courses, it's very common that, oh yeah, each week there's one page that students navigate to regularly. And on that page are a bunch of external links or Panopto videos are embedded or something like that. That
Mm,
totally makes sense that they would go there and like if they're on track, they should be doing that. So in a way, I don't care about
yeah.
the number of clicks. It's more just a number of sessions. Um, so yeah, it sounds like that there might be some options for that if that's something that we wanted.
Yeah, absolutely. Yeah, if you engage with the interaction session mart and you find some gaps there, that's definitely something that we want to work with you on, and sort of improve that.
And I know, you know, from my process of making the performance outlook and looking at just the different features that were available in the data mart, specifically the task force data mart, this isn't a perfect solution to that issue that you brought up, but there's a lot of other features that kind of help explain some of that missing variance of, for example, the number of tool launches, numbers of files viewed, things like that as well. So I know I'm plugging in a bunch of those other features as well to help fill in some of those gaps about, what students are doing actually in Canvas. Just wanted to throw that out there. It doesn't perfectly address that specific issue, but
Hmm.
Yeah, no, it helps. Yeah, thank you.
I'll endorse. I think what you concluded to is there's multiple ways you can measure this, the number of clicks, or you know,
Yeah.
but this is useful if you want to sum up time. You have to do some kind of inference like this to sum up time, and then there is, as you said, there's guesses in that. Also, point out, Kyle, you talked about tools, but Canvas itself gives us a giant blind spot on clicks within a quiz because they're not
Yeah.
reporting that to Caliper.
Yes.
And so
Yep.
in structure itself could help with some of this, and they have not stepped up to the game on that. All right, so
Yeah,
that's my
totally.
responding to you. And I had a question for Liz on sort of how you navigated. You sort of implied, but I just wanted to come back to that notion that Canvas scores there's some edict against using Canvas scores, and yet you're using Canvas scores in this sort of black box. So everybody is okay as long as it's kind of wrapped up into a black box. They just don't want to see exposed real-time Canvas scores to others. Is that how that got interpreted? Or is that sort of from the beginning that was interpreted that way? Or did you have to kind of push around, or are you sort of ignoring that?
not ignoring it, hopefully. um, yeah, no, that's a great question. So um, it's part of the reason that this project is sort of packaged the way it is in this intentionally obfuscated bidding system. And we put a lot of care into which specific weekly metrics we want to include or not, because we do need to respect Penn State's, we can't share grades in real time. And even if we wanted to, as I mentioned, there's so many caveats to that because Penn State doesn't have standardized use of Canvas. So we see this a lot with looking at different edge cases when I'm checking how things are with the model of certain courses, who knows when they update their grade book, if they do it consistently across all students at the same time, if they use a standard grade book. There's courses where a student can have 200%, but that doesn't necessarily mean anything. So even the schema of the course structure varies and isn't standardized. So the approach for us is just to kind of do something similar to what Unizin did to crack this nut of like, let's just say how this student's doing relative to other students in the same course section. And that's perfectly within in the rule book, and that's not upsetting anybody. It's giving advisors a sense of, hey, this student's, in the bottom, whatever, 20th percentile compared to other students in this course. take that as a grain of salt because we cannot guarantee that this is even up to date, the grade book. But it's our best attempt at filling in those gaps. And in a lot of ways, it's very similar to what we're doing with activity data, which is, we're anchoring that based on the context of how other students in the course are engaging. Because a lot of these metrics, if you don't do it relative to other students in that same course, specifically that course section, ideally, it's kind of meaningless. For example, looking at the number of files viewed for one course could mean one thing, and then for another course mean something totally different. Actually, a great example of this is number of missing assignments. For some courses, one missing assignment is a big deal. For other courses, you can have 8 missing assignments just because of how the instructor formatted things whenever they were putting it into Canvas. And sometimes those missing assignments might even be like worth 1 point or something that doesn't even impact their grade. So to answer your question, we know that we're kind of like straddling this line that's a little fuzzy. And we're trying to own that and talk about it. That's part of why we're doing this as a pilot, to get people's feeling of, is this helpful how we're doing it? Is it crossing any lines? But so far it's been overwhelmingly positive, and that comes from leadership as well, and helpful. And we've got feedback too, which has been really rewarding from instructors who teach some of those courses with the weird grade books. And getting them to corroborate this relative approach and its sort of validity has been helpful in our design. And as I mentioned, we're constantly refining our logic and expanding our scope. So it's a process that's still unfolding, and we're still getting.
So it wasn't the information per se; it was that it was without context, and so you're providing some of that context of relative to, and that seemed to satisfy some of the concerns of that initial.
Yeah, and also all you can do with that information is understand how the student's doing relative to other students in the course. Saying somebody's in the 20th percentile in a challenging, Calc 2 means something totally different than somebody in the 20th percentile in their, freshman English class or something. So we took a lot of time and care and conversations with other stakeholders to decide what information is helpful. We don't want to include anything that's not helpful. There's no like superfluous stuff that we're just sending because, we have the time or whatever. But also ensuring that there's no possible way for advisors to reverse engineer a grade, because that's a line in the sand that's specific to Penn State. I'm not sure how many other universities have these specific boundaries, but it's a conscious part of our design and thought process when handling this problem.
Thanks.
Yep, thanks.
Kyle, there's one question from Ryan in chat that I'm not sure if you can weigh in on, or maybe others that do work with both the UDP and raw CD2 might weigh in on there as well.
Let me read it real quick. Assignment submission is partly because LTI-based actions aren't always generating the data we expect. Yeah. The LTI launches are tricky. And I think this also echoes a little bit of Chad's point. So from the UDP perspective, the Caliper event stream is sort of the best record that we have for the stream of activity. But sometimes we get thin events, or like once an LTI is launched, then we only know that it was launched, but we don't know anything else that happened inside of that LTI unless that tool has its own native Caliper event stream. So that's sort of the weird nature of the ecosystem right now. And Canvas is Instructure is just as much part of the problem as part of the solution, right? I think new quizzes is, I think, a good example. So we see Quizzes 2 is the name of the application that gets launched. So we know when students start a quiz, but we don't know when they finish a quiz, when they click different questions or anything like that. It's sort of it's still a very fragmented sort of ecosystem. One resource that could be leveraged, but it's a costly resource and it's not one that we readily provide, but we can pull, is the weblogs table. It used to be called the request table. That is not a great resource for learning analytics, but it is a good resource for sort of system forensics in a way. A lot of times people pull that when they have, honestly, some legal requirements for a full sequence of what happened in a system. So if there is like a blind spot that you see on the caliper side, we sometimes can pull the request table and then look at that same time window and see if there are extra records that are stored as a log that weren't caliperized. So, okay, but it's still missing stuff. Yeah. Then it's likely that sometimes the LTI, it beyond the launch, it just doesn't give us any visibility.
We are 1 minute over. I want to say thanks again. Thanks, Liz. Thanks, Kyle. Much appreciated. Thanks, everyone, for tuning in. Keep on the lookout. We're probably going to do this webinar series again in 2026. So hope everyone has a nice holiday and the rest of the week. Have a good afternoon.
Thanks, everyone.